Hi, this is Math 2510, and this video is going to be over section 6.3. And we're going to be looking at calculating volumes of based on functions that we end up rotating around either the x-axis or the y-axis, or maybe some axis parallel to one of those two. We'll be doing this through a few methods throughout the next couple sections, and they all involve integrating. So we're going to start with kind of the basis idea of this. So we're going to look at volume by slicing. So imagine a volume of a solid bounded by two parallel lines that are perpendicular to the x-axis. So we end up with, let's say, a cylinder here. We cut the cylinder into slices. Okay. The cylinder, each slice is going to have an area of A and have a height h. And so that's how you'll get a volume of either one slice, and then to get the volume of the whole thing, you add up all the slices. So we're looking at summation of the area times height from 1 to however many slices. Right, but sometimes, or most of the time, your slices aren't going to be the exact same, and they're going to change as we go across the solid. So for instance, the solid is broken up. We have these rectangular slices, but they increase in size as you go from left to right. And so for this, you'll have the summation as I goes from 1 to n of the area, evaluate at x sub I, and then delta x, however, wherever the width of these slices are. And you're adding these up, it'll get the value. Okay, and the area is going to have a specific formula that we're adding up. All right, so let's start with just a base. This volume is going to have a base, and we want to find the area of one slice. Remember that the base of this slice will be plotted on the coordinate system. Each slice will have a width of delta x, and then integrated from A to B on here. So if we're looking at a circular base, of radius 1, so that's 1. And then we're going to have square parallel cross sections. And so middle will have a square cross section that is a size of 2 by 2, since the base of it is 1 for each radius, so the diameter is 2. And then here it's going down to 0 there, so about maybe here we'll have a 1 cross section. And so we'll end up with this kind of unique kind of shape to it. That's one side, and then it kind of goes on the other side backwards. All right, so if we look at the base, your x squared plus y squared is your base, and the cross section is a square. You have y by y, so the area is equaling y squared, and y squared here is going to equal 1 minus x squared. So your area then is equal to 1 minus x squared. Okay. So if we look at the volume, when we integrate an area with the width of dx, this area is going to go from -1 to 1 since the radius is 1. So we have integral from -1 to 1 of 1 minus x squared dx. And so when we integrate that, we get x minus x cubed over 3. Integrate from -1 to 1. Which is going to be 1 minus 1/3 minus -1 plus 1/3. So that would be 2/3 minus -2/3. So 2/3 plus 2/3 is 4/3. Alright, so in this next one, we'll have two different parts to this. So the first part is we're just going to find the area. And we're going to find the area by integrating. And so we have y equals x squared. The area is going to go from 1 to 4, since it tells us 1 to 4, of x squared dx. And so when we integrate this, we get x cubed over 3 by away from 1 to 4, which would be equal to 4 cubed over 3 minus 1/3, which is going to be 64 over 3 minus 1/3, 63 over 3, which is 21. So the area there underneath this curve from 1 to 4, this area equals 21. Now we want to use these triangle cross sections as we go across. Now the area here is 1/2 base times height. Okay, for our base, what we're going to do here, so this is going to be our height. We're going to let this be y. So the whole base is 2y, so these sides are 2y. Okay, so this height, which is not the hypotenuse, the hypotenuse is 2y squared. I'm sorry, hypotenuse is 2y, we're going to square it. That Pythagorean theorem, that's going to equal h squared plus y squared. So h squared would equal 4y squared minus y squared. So h squared equals 3y squared. So h equals square root of 3y. Y square root of 3, right, that way. And our base again is 2y. So the area is 1/2 times 2y times h, which h is y square root of 3. And so the y's cancel out, you get square root of 3 y squared. Or the 2's cancel out, you get square root of 3 y squared. Okay, so now we're going to integrate that volume from 1 to 4. This is, we have to have this in terms of x. Now y squared, remember y squared is x, y is x squared, so y squared is x to the 4th. So the area is going to be square root of 3x to the 4th dx. And so we will get square root of 3 x to the 5th over 5. Integrate from 1 to 4. The square root of 3 over 5. 4 to the 5th minus over 5 minus 1 over 5. just square root of 3 over 5 times, let me see what 4 to the 5th is, 1024, so 1023 over 5. Okay, so this is going to be square root of 3 times, see if I divide this by 5 twice, 4092, which is about 70.88. One second here. You know what? I made a little slight error. So I pulled that 5 out, but then I had the 5 divided here. If I pulled the 5 out, I don't want to divide the 5. We have a 5 that we shouldn't be dividing by. So we just multiply this by 5. Do this again. So 1023 divided by 5 is 204.6. So that's times square root of 3 is 354.38. I knew I had too many 5s. Looking at it thinking, why is there so many 5s sitting on this? Alright. So now we have this idea with the base and the cross section. We're going to look at revolving something around an x-axis or a y-axis. I think we're going to do x-axis, and then that's where I'll start the second video for this. So if we take this shape here we have that looks like kind of a slice of a pear, revolve it around, we get this 3D image to it that has all these different slices. And so in this case, we're revolving around the x-axis. So that's the idea. Now, we're going to take that shape and split it up into cross-section discs. And if you notice, your function, this stuff here, your function goes from the x-axis to there. And that would be your radius of any one of these discs. So we take one disc, radius is just that section of it, 0 to the function. So we have what a radius is going to be as we spin this around, and this disk is then going to have a cross-sectional area that is pi r squared, which is going to be pi the function squared. So a volume is going to be the area of the disk times delta x, which is going to be pi r squared times delta x, which is going to be pi the function squared delta x. And so we get all these disks that we're summing up to build this volume, and the function is going to change the area as we go along. So we end up getting an integral a to b pi the function squared dx. Right, so let's get to an example here. We're going to rotate sine around the x-axis, bring what looks like kind of like a football or lemon. And this is only going to go from 0 to pi. So we're going to have 0 to pi sine squared x dx. Now we're going to have to bring in some trig identities here as we go through. Okay, so the first trig identity we have to bring in is sine squared x plus cosine squared x equals 1. So we can write this as integral from 0 to pi of pi cosine squared x. Oh, sorry, hold on. 1 minus cosine squared x dx. Because if we solve this for sine squared x, we get 1 minus cosine squared x. Okay, now, about cosine squared x? Well, we bring into account the fact that cosine of 2x equals 2 cosine squared minus 1. There's another trig identity. Now for that, we can solve this for cosine squared x. So cosine of 2x equals, let me add the 1 over, plus 1 equals 2 cosine squared x. Cosine squared x equals cosine of 2x plus 1 all over 2. Right, so we'll write this out now. 0 to pi 1 minus cosine of 2x over 2, and minus 1 or plus 1 half, but it's minusing cosine this, so it would be minus 1 half dx. Okay. So now I'll rewrite this one more time. 0 to pi of pi, I'm going to bring the pi outside. That way, with that last. Then 1 minus 1 half, it's going to be 1 half minus cosine 2x over 2 dx. Alright, now we can integrate this. When we integrate this, we want to make sure that we take into account that it's a 2x and not an x. So when we integrate this, you'll get pi. Make sure that this is still recording. Pi times 1 half x minus sine of 2x over 4, integrated from 0 to pi. Okay, so the antiderivative with 1 half is easy. We take derivative of that, we get 1 half back, no problem. If we take the derivative of sine of 2x over 4, well, you'll get cosine of 2x over 4. Then you multiply that by 2 because of the inside chain rule, and that drops that denominator down to 2. So you end up with cosine 2x over 2. That's why there's a 4 there, is to account for that 2x. Alright, so now we have to apply our limits. Now, notice that if you include 0 into either one of these, you get 0. Sine of 0 is 0. 1 half times 0 is 0. So we don't have to worry about that bottom limit. That's always nice when that's the case. So we'll have pi times 1 half pi minus sine of 2 pi over 4. And then this is also 0. So it becomes just 1/2 pi squared. You can see what value that is. So pi squared times divided by 2 is 4.93. Right. So let's look at now the volume of x squared, and we're going to rotate this over the x-axis again. We're going to go from 0 to 4. 1, 2, 3, 4. Well, 4 squared is 16. So 2, 4, 6, 8, 10, 12, 16. And then it's a 1 and 4. And we're rotating this across the x-axis, so it becomes what looks like kind of a loudspeaker. So the integral is going to be from 0 to 4 of pi times x squared, write that, x squared squared dx. And so we'll get integral from 0 to 4 of pi x to the 4th dx. When we integrate this, we'll get pi x to the 5th over 5 integrated from 0 to 4. So 0 again, limit, makes that 0. We don't have to worry about the bottom limit. Get pi 4 to the 5th over 5. 4 to the 5th is 1024. 1024 over 5 pi is going to be 204.8 pi. 643.4. Alright, so now we want to find the volume of a function x squared minus 6x plus 11, and it's rotated around the x-axis between 1 and 5. Alright, so the way this looks is if we plug in 1, so we're going to do 1, 2, 3, 5 is here. If we plug in 1, we get 1 minus 6, which is negative 5, plus 11, which is going to be 6. So it's right here. And it's going from that spot. 5, we plug in that, we'll get 25 minus 30, which is negative 5, plus 11, which is 6. So it's right back at the same spot. Then we can plug in some of these other values as well. If you plug in 3, so it's in the middle. 9 minus 18, which is negative 9, plus 11, which is 2. Plug in, I said 2, but then I probably got 1. 2. We plug in 2, we get 4 minus 12, which is negative 8, plus 11, which is 3. When we plug in 4, we get 16 minus 24, which is also negative 8. So we have 3 as well. So it looks like this. And we are, again, making this across the x-axis. So it starts to look like an hourglass in a sense. Looks like this, and then the middle section is a little bit thinner. So sideways hourglass. Alright, so integrating this from 1 to 5, we have pi x squared minus 6x plus 11 squared dx. And we're going to multiply this out. So I'm going to multiply it out up top here. Right at the same time. So we get x to the 4th. And x squared times the negative 6x is negative 6x cubed. And we'll have 2 of those. So we'll have negative 12x cubed. Then we'll have 11x squared, and 11x squared will be 22x squared. And then we'll have 36x squared as well. Let's see, I did x to the 4th, x cubed, x squared, x cubed, x squared, negative 66x. We'll have 2 of those, so we'll have negative 132x, and then 121. And the 2x squared is going to be 58 now. Let me make sure I have the signs right with those. 11 is 22, 22, 36, yeah. Alright, so write this now. Integral from 1 to 5 of pi x to the 4th minus 12x cubed plus 58x squared minus 132x plus 121 dx. Just want to double check my math here. So x squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times 11 is 11x squared. That's positive. And negative 6x times x squared is another negative 6x cubed, so you get negative 12x cubed. And then negative 6x times negative 6x is 36x squared. And then negative 6x times 11 is a negative 66x. And then you'll have 11 times x squared is another 11x squared. That's where we get the 22. 11 times negative 6 is another negative 6x. That's where we get the 132. And then 11 times 11 is 121. Okay, so yeah, that should be positive 58. All right, so now we integrate pi x to the 4th over 5 minus 3x to the 4th. I'm sorry, x to the 5th over 5 minus 3x to the 4th plus 58x squared over 3 minus 66x squared. Why am I forgetting to raise this power? X cubed and then minus 66x squared plus 121x. All integrated from 1 to 5. Alright, so now we'll plug in the 5. We have 5 to the 5th over 5 minus 3 times 5 to the 4th plus 58 over 3, 5 cubed, minus 66, 5 squared, plus 121 times 5, minus 1/5, minus 3, plus 58 over 3, minus 66, plus 121. So let me get some of these values here, especially the whole numbers. Make this kind of easier. So 5 to the 5th divided by 5 is 625. 5 to the 4th times 3 is 1875. 5 to the 3rd is 125. So you get 7250 over 3. And 25 times 66 is 1650. And 21 times 5 is 605. Minus, let's see what we can, you know what, let's do it this way. So, minus, and we'll do the numbers first. So 121 minus 66 minus 3 is 52. And minus, make that plus, minus 1/5 minus 58 over 3. And always subtract the 1/5 at the end. I want to minus the 58 though, so I can make that go with the 7250 over 3. Right, so we have pi. Let's see here. Get all these numbers together. 625 minus 1875 minus 1650 plus 605 and plus 52. Negative 2243. Then plus, or do 7250 minus the 58. 7192 over 3. And then minus 1/5. Right. This is something we can now plug in, actually get a value, and not be too bad. So 7192 divided by 3 is 2,397 minus 0.33. So minus 1.1 divided by 5 minus 2243. I get pi times 154.13. This is going to be 484.22. Alright, so that's going to be the end of this video. And then in the next video, we'll cover the y-axis, and then we'll get into what's called washers. Alright, and I'll see you then. Bye.